All right, guys, welcome back. We're looking at the next math notes here. 5.3.3 equations for sequences. We're going to learn how to write some equations based on sequences here. So arithmetic sequences, the first ones. Remember, arithmetic sequences will give us a line. They're formed when you add a common difference to each of the terms, such as plus 2, plus 2, plus 2, plus 2, as you're moving down the line, or just adding 3 to everything. The explicit equation for the arithmetic sequence is t of n equals m times n plus b. And if you're clever, you might notice that this is really close to y equals mx plus b, except that because we're talking about sequences, we're talking about discrete functions here. All right, so instead of creating a line, we're going to create a series of dots that go in a line. Okay. N is the term number. B is going to be our starting value. Starting value. It's also t of 0, so it's your 0th term. M is still your slope, which is the same thing as the common difference in a sequence. Okay, and n is your term number. Oh, they've defined all these right here for us too. So n is the term number, m is the common difference, and b is the 0th term, also known as the starting point or initial value. These equations are similar to the continuous function f of x equals mx plus b, or y equals mx plus b, where m is the slope and b is the y-intercept. For example, the arithmetic sequence 10, 13, 16, 19, which we can assume is term 1, 2, 3, and 4 in the sequence. And we can see that we add 3 to move to the next term for all of these. So our 0th term must be 7, because 7 plus 3 gives us 10. That means that we can generate this equation. T of n equals 3n plus 7. So that's the 0th term. There's our slope or common difference, and that gives us the equation. So if we wanted to know the value at the 21st term, then we could come in here and put t of 21 equals 3 times 21 plus 7, which would give us 63 plus 7, which would tell us that the 21st term of this sequence is 70. An alternative notation for arithmetic sequences is a sub n equals mn plus a sub 0, where n is the term number, m is the common difference, and a sub 0 is the 0th term. So we can switch back and forth between these different notations. The only real advantage here is that it tells you that this is your 0th term and your starting value, and it's sort of built into it with the a sub 0. Okay, so using the alternate notation, this one up here, t of n equals 3n plus 7, becomes a sub n equals 3n plus 7. Not that different. So geometric sequences. Remember that geometric sequences have a common ratio. Or a multiplier. That when you graph them, they give you an exponential function. All right, so the explicit equation for a geometric sequence is t of n equals ab to the n. Again, this should look very similar to our general form of an exponential equation, which is y equals ab to the x, where n is the term number, b is the multiplier or common ratio, and a is the 0th term or the starting value. An alternate notation for geometric sequence, just like above for the arithmetic sequence, is a sub n equals a sub 0 times b to the n, where n is the term number and b is the common ratio, and a sub 0 is the 0th term. So let's look at an example here. This geometric sequence, we have 6, 18, 54. So our common ratio here, which we could get by doing 18 divided by 6 and getting 3, or by recognizing that 6 times 3 is 18 and that 18 times 3 is 54, can be represented as t of n equals 2 times 3 to the n. So here's our multiplier, or the common ratio, that's the 3 right here. The 2 is our starting value, or our 0th term. So again, we have to go backwards. If this is the first term, second term, third term, our 0th term, we have to divide by 3 as we go backwards. Or we say that 2 times 3 would give us 6. So that's our 0th term. And these are called explicit equations because all you have to do to get the answer is plug in the term number. So if we wanted to know what was happening on the, say, the 5th term of this equation, then we would just plug in 5 for n and get that equation. 3 to the 5th. Not sure I know that off the top of my head, so let's do this here. It's 243. So twice that would be 486. So our 5th term here is going to be 486. Okay, so a recursive sequence is a sequence in which each term depends on the terms before it. The equation of a recursive sequence requires at least one term to be specified. A recursive sequence can be arithmetic, geometric, or neither. So for an example, we have the sequence 3, 11, 123, 15,131 can be defined by the recursive equation t of 1 equals 3, t of n plus 1 equals t of n squared plus 2.